given that 4 minus I bracket square plus 8 lambda plus I, 3 minus I plus AI equals to 43, we want to find the exact values of the real numbers, lambda and mu. So this is a simple question that's a matter of equating the real and imaginary parts. So what we're going to do is just to take the question as it is and expand everything and eventually pull out all the real and imaginary parts together. Alright, and so with that, we expand the first portion, 4 minus I squared, we have 16 minus 8I minus 1, right, on okay, so this is just minus 1 plus 24. Similarly, I expand my right hand side sincerely and honestly and carefully, making sure that I do not make any careless mistake, because this is not a difficult question. It's just one where you need to be very careful while expanding your terms, right? And after which I basically group all the imaginary and the real parts together, right? So I have 16 plus 24 lambda mu plus I of 3 mu minus 8 lambda minus 8 equals to 43 minus 8I, right? And if I equate the real and imaginary, so basically now I have my real and imaginary parts standing side by side, right? So I'm equating the real and the imaginary parts, right? I have 16 plus 24 lambda mu to be equals to 43. I have 3 mu minus 8 lambda minus 8 to be equals to negative 8. Right, so let's say I call this equation 1, I call this equation 2. Alright, so you just try to solve this. Alright, for lambda and mu. Eventually you're going to get mu to be plus minus square root 3 and lambda to be equals to plus minus 3 square root 3 8. So I'm not going to go into detail how to solve. I hope you can do, right? Then next up, for 4b, given that the complex numbers w and z satisfy the equation, find w and z in the form of a plus b. So this is a question about simultaneous equation substitution. Right, usually now we see that there's a w, so what you can do is you can use z to be the substitute. Usually we choose the one which does not have conjugate appearing, because if we choose w does not work, we just choose one that has conjugate, it does not work. Okay, so with that we have the first equation. Second equation. Alright, basically what I do is I choose z to be the substitute. Alright, so this is 1, this is 2, and from 1 I will sub z to be equals to I minus w asterisk over 2 into equation 2. Alright, and then with that I have w plus 1 minus 2I, and z will be I minus w asterisk over 2, right, equals to 3 plus 3I. Right, slowly I'm going to try to simplify. I will have maybe I multiply all by w. Sorry, I multiply all by 2. This is what I get. Alright, and hold on a second. Okay, so this equals to 2 bracket 3 plus 3I, and I simplify this, I expand, I will get 2w plus w asterisk 2I minus 1 equals to 4 plus 5. This is after simplifying, so I'll leave you to work it by yourself. Then what I can do is now I can actually proceed to find w, but maybe I let w to be equals to a plus bi first, then I find it. And next, 2w plus w asterisk 2I minus 1 is equals to 4 plus 5I, right? So we sub w to be a plus bi, that means w asterisk will be equals to a minus bi now, right? So this equals to 4 plus 5I. Again, I simplify this. I simplify this and I try to group the real and the imaginary parts together. I put the real and the imaginary parts. So I'm going to get a plus 2b plus 2a plus 3b I equals to 4 plus 5i. Okay, and after that I compare the real and the imaginary part. So this is equals to this, this is equals to this. This is comparing the real part, this is comparing the imaginary part. Alright, so a plus 2b is equals to 4, 2a plus 3b equals to 5. Equation 3, equation 4. Now you solve these two, you're going to get a equals to -2, b equals to 3. Alright, so w is equals to -2 plus 3i. Alright, with that, quickly you can also find your z. You know that your z is equals to I minus w asterisk over 2. So it's the same as I minus -2 minus 3i over 2. Alright, yeah. So you solve this, you're going to get 1 plus 2i. Okay.